So I think the whole idea of this webinar is to kind of be a starter intro to cloud security in AWS and to kind of go over some of the key decision points and or lessons learned from Notre Dame as we've gone to the cloud and specifically within AWS. Um, so this is my introduction. I'm James Smith. My current title is the Associate Director for Cloud Engineering Services. So I lead a team of cloud engineers to support all of the operations at Notre Dame from a cloud perspective in AWS. So we support research, we support the enterprise systems from Banner to the student systems to our document management systems. And we also support lots of other groups like the library and engineering and science computing. So my experience and background is I started in information security in 2011. I was part of the team when we migrated to AWS and had the whole Cloud First project. When I left the team, I was the security architect. And throughout that time, I did lots of things like data loss prevention to firewall management to you kind of name it. In 2019, I joined the cloud engineering team as a cloud engineer and then slowly became the cloud architect. And my current role is the associate director for cloud engineering services. I've also taught privacy security at the university for a little bit. I've had a number of certifications, but my most recent experience is amateur race car driver. So I like to say I drive slow cars fast. And so I drive across the country and compete in events. So that's what I like to do as hobbies. Um, but I'll digress. So today, I think the agenda should be, we'll go over the cloud journey of Notre Dame and how we kind of went cloud first. And around 10 years ago, we started that journey. We'll talk a little bit about AWS's global infrastructure and the shared responsibility model, because this is one of the most key important things you need to know when considering migrating to AWS and foundational for security for that matter. We'll talk about governance and AWS account management. And within there, there's topics around foundational security, organizations and control tower, and then identity and access management service. We'll go into infrastructure and data protection, and finally incident response, and we'll end with questions. Feel free to put questions in anytime though, because ideally this would be interactive. And if you have specific questions about how we've implemented things or about considerations, I'm happy to answer those questions. So I know it's a lot of information and I think that's okay. I'm happy to help. At the bottom of every slide, I'll try to put in references that you can click on and reference. I'll also have links periodically within the presentations as well. So Notre Dame's cloud first journey started really in 2012. We partnered with AWS as our sole cloud provider at the time. At the time, if you had looked at a Gartner quadrant, AWS would have been at the far right, way ahead of the competitors. I think since then, they've kind of caught up some, but the idea was that we would partner with one cloud provider to kind of build the solutions, and so they could work with us to grow their platform and our own. So in 2012, a group of Notre Dame folks went out to Virginia, met with AWS, and then talked about moving our main website out to AWS. And so we did that in 2012. And the idea would be that we could scale up in an event where we might, say, win a national championship. This was really actually tested, though, when one of our former presidents, Father Hesburgh, passed away, and we could see the website scale up using auto scaling and the infrastructure grow without any kind of outages. In 2013, we had a lot of major decision points come through for like our core infrastructure and aging hardware. So we kind of made a commitment to test and pilot to see, could AWS actually work for us? Would this actually be a solution that could work? So we had some pilots out there for the core infrastructure, things like DNS, things like authentication, and those ended up working quite well. We moved our mobile application out and even some backups up there. So once those pilots worked out well, in 2014, we were like, we're all in. And so we picked an arbitrary number of 80% to move of our infrastructure to the cloud by 2017. I think that number was picked just because another university said they wanted to move 75%. So, and anytime you have any questions, or I'm sure a lot of people may have heard this story, and I linked at the bottom there a link to some articles with ServiceNow that are publicly accessible for folks for reference. So getting started in the security piece of it, understanding AWS's global infrastructure is critical to understanding how to protect your resources. Just from the standpoint of if you don't understand where your resources are, how could you ever secure them? So it's important to kind of understand like what kind of infrastructure is on that backbone. So AWS actually has around 33 geographical regions. This was accurate as of a few nights ago when I made this slide. And each region is composed of 3 or more availability zones. And so there's actually 105 availability zones out there currently. And each one of those availability zones is 1 or more data centers, very large data centers with redundant power and networking and connectivity to the other pieces of that AWS region. So to break that down even further, like I said, each region consists of multiple availability zones, and each one of those has 1 or more data centers, and they're all interconnected. And so this is kind of what that picture would look like if you zoom in some. And if we zoom in a little bit more, this is what it kind of looks like. So every single region has multiple transit centers that are then interconnected between all the different availability zones. And each availability zone has interconnections within itself. And all of this is to improve reliability. Um, and scalability as well. And another key thing to note here is all of these availability zones are within geographical significant distance from each other, but also close enough to have good speeds. And so what that means is if there's a if there's a disaster, then and you lose an AZ, you're still not going to take down the region. So that's a very important concept to understand. I know I'm going pretty quickly, so I'll try to slow down. So all of that kind of leads into this idea of the AWS shared responsibility model. So this responsibility model is like one of the most critical things to understand. When we were first getting into the cloud, there's this, some people had misconceptions that AWS would just take care of all the security for you, and then some people thought none. So it's really important to kind of lay this out as foundational to leadership as you're considering a cloud journey. And even the security team, as you're kind of building things out, has to know each piece of this. So the idea is that AWS is responsible for the security of the cloud, and your organization is responsible for the security in the cloud. And what that really looks like is 3 different types of controls. So some of these controls are actually just inherited by being in the cloud and being within AWS. And these are things like your physical environmental controls. So if you look at that, all the orange layer, all that is things that AWS takes care of for you. And if you ever have questions about like, what does that mean? You can use a service called AWS Artifact, and you can download their SOC reports, and you can get an idea and understand of like what they take care of from the actual physical and environmental perspective. Then there's a next layer up called shared controls. And this is where like Amazon will patch that core infrastructure, but as a customer, you're still responsible for patching the actual applications and OSs that you build on top of that core infrastructure. And then also the configuration management is kind of shared. And that is because some of the services within AWS are AWS managed, which means they may take care of some components of that resource as far as patching. A good example of services of that is the relational database service, where you can schedule patches regularly, but you still need to make sure that you have your main versions up to date yourself. And then finally, there's these customer specific controls that only you're responsible for that Amazon will not do for you. They may give you tools to make sure you're doing these the right way, but they're not going to do that for you. And a lot of this is around design work and implementation. And so that's where it's key to engage all the different experts across your organization to make sure you're doing this right. And I should have mentioned that on our Cloud First program, we had around 30 different cross-functional team members. Since then, the cloud engineering team that I'm on has taken over quite a bit of these responsibilities from this perspective, but we made sure to get everyone involved early on in terms of the initial network design, the security controls that you want to put in place, how you do your backups and disaster recovery is majorly important, especially around the shared responsibility model. And that's because if you don't understand how the regions work, if you don't understand how availability zones work, there's actually been customers that have gone out of business. So folks that were on AWS that had to close shop because they didn't understand this idea of a shared responsibility model. This example is from 2014, but then there's been examples as of a couple years ago, where a customer deployed resources to only one availability zone, and they did not have backups and snapshots that in place. So when the availability zone went down, their resources were gone. So it's vastly important to understand the shared responsibility model. So next, I want to take a minute to talk about governance and account management. And so with this, there's this idea of this foundational security layer with AWS, and it's important to understand and think through all of these as well. So knowing identity and access management, what that service is, what it means for you is foundational. That's one of the most important services with AWS. And then maintaining traceability. So this is all your logging, your monitoring, and your alerting throughout your environment. As you're building it out, having that in place ahead of time makes it a lot easier than trying to retrofit that back in, which that goes directly into applying your security at all layers. So building in your security at the beginning rather than trying to bolt it on at the end to meet some kind of compliance regulations is critical. Because if you can build security into all the things you do in the cloud, then it makes it much easier to meet any kind of compliance requirements later because it's just something that you do. So along that same lines is like if you can just protect all the data in a transit and at rest with encryption, make it really easy. You don't have to necessarily even think about it going forward because it's all just there for you. And that goes into play with the next thing is like automating all your best practices from a security perspective, building in guardrails can really help you out later down the road. And then thinking about your multi-account strategy. And this is something that we struggled with initially because we didn't have the resources and the capabilities in say 2016, 2015 timeframe that we do today within AWS to be able to support this idea of a multi-account strategy. But what this really means is like building in these natural security boundaries by having separate AWS accounts with different permissions is a huge benefit because then you can build AWS accounts that are specific to either teams or projects or even sometimes specific services. And having that planned out from an architectural perspective ahead of time makes things a lot easier. And then your billing and finance team will also thank you because if you have certain projects that you need to tie back in the billing, it makes it a heck of a lot easier. Oh, so there's a question. Let me take a look. So Tim asks, how do we know which alerts to turn on without having alert fatigue? So that is a good question. I think what we've done as far as Notre Dame and what I would probably think about as well is like working with your security team. If you are on the security team, I'm sorry, I don't have a good answer for you, but working with the security team to figure out what are those high level alerts that you want to necessarily be woken up in the middle of the night for, and what are the ones that you want to just be in a queue for someone to pick up like your stock team later down the road. And so some examples of things that we do immediately alert on are like guard duty alerts, which is a tool built into AWS that you can enable across your accounts that uses machine learning to look for high level issues from a security perspective. And within there, they label them at level like 1 to 10. So we'll have anything from like 8 to 10 automatically trigger a ServiceNow incident for our InfoSec team. So an examples of that is a machine in your VPC that's connecting out to a command and control, a known command and control. That's something that you kind of want to know about right away and that you want to take action on. Other things may be just audited. You want to be able to audit that. So hopefully I answered the question. So for governance and account management perspective, there's lots of tools to consider when actually deploying new AWS accounts and an organized and a whole environment. So the first thing and lesson learned that we kind of had was you want to make sure that you federate your access to AWS as soon as possible. Don't try to retrofit that back in. We did not have a good answer at first. So at first we just had a lot of local users deployed. And what that means is you're managing these users, their multi-factor, and the policies and permissions associated with groups all by hand, and that was a nightmare. So what we've done since then is try to federate all of that access with our central authentication system. We utilize Okta, but you could also use any other kind of tool that you're using for your identity provider. And what that means is we can do auto provisioning of users and groups into, in our case, Identity Center from Okta, and we automatically do that deployment using Active Directory SCIM integration. So anytime we have a new group or role that we want to deploy or a new AWS account, we do some automation to automatically deploy those groups, add the memberships, and assign those permissions out, which makes it a lot more simple than having someone go in and do that automated or manually. And then also it's really nice for, as you know, life cycling accounts. If someone leaves the organization, their accounts are automatically deactivated. And so we don't have to worry about missing someone when they leave, going in and deleting that user or removing the permissions or putting them in kind of like a cold state. So that's been a huge lesson learned that we kind of figured out that you need to do early on. Another thing to consider is utilizing tools such as AWS Control Tower with organizations. We did not have that at first. So when we were actually creating AWS accounts, it was through credit cards and creating emails and assigning them up with credit cards. Nowadays, it's so much more advanced. They have a service called AWS Control Tower that utilizes organizations that lets you organize your account structure in terms of organizational units. And this allows you to automate policy attachment and then also do controls and services at the organization layer. And then also do some really cool automation. And so some also benefits of this is you get centralized billing and alerting you can do. So I keep coming back to costs, and I know this is a security webinar, but in terms of the cloud, I always say follow the money in terms of how can you utilize cost information to detect indicators of compromise. So in our environment, and it's highly recommended best practice is to enable this idea of cost anomalies. And what cost anomalies are is this artificial intelligence back-ended, I know it's a buzzword, but artificial intelligence back-ended system within costs within AWS to then let you create like a daily type budget across all the services, across all of your accounts. And if you pick a number that kind of makes sense for your organization, that if you go over this daily budgeted amount, that it'll automatically create an incident for you. It's been huge for us. So an example of this is we had a CloudFront distribution fronting some websites that was getting hit by a crawler. And we saw that on a daily basis, our normal spend was maybe $3. And in this case, it went up to $350 a day. So we were able to then get notified of this, had an incident created, and then respond to that, and then block that crawler with CloudFormation and using a web application firewall to prevent one, cost being high, but also potentially protect our assets. So that was a big deal. And so cost anomalies can be huge from protecting you, but also from a financial perspective as well. Another thing to consider is the idea that you want to deploy resources in an automated way using AWS CloudFormation stack sets. So this is a way to deploy infrastructure as code based on organizational units to build out that common infrastructure across all of your accounts. And we do this through infrastructure as code with CloudFormation. And some examples of that are building out those security guardrails by default. So things you can do back in the day was like enabling guard duty across all of the AWS accounts. You can enable config recorders to automatically record all of your resources to a central location using this method, deploying roles and permissions across all of your accounts based on organizational units. All those things are possible using CloudFormation infrastructure as code. And then finally, being able to share common resources that you've already built to organizational units using Resource Access Manager. So a good way that we utilize this is we have a central VPC or virtual private cloud network that we want to share out to all of our production resources for use. We want to do that based on the organizational unit of it's a centrally managed account. It needs networking access to our on-prem and cloud resources, and we want to deploy that in an automated way so we're not managing private custom VPCs for all new accounts. So we share these central VPCs using what's called Resource Access Manager. Another configuration item that you can use with it is your DNS configurations as well. So you can leverage DNS across your managed accounts. So there's another question. So Tim asks, how do you ensure that there aren't any accounts or identity access that lingers that are not supposed to be there, i.e. an employee that has been terminated or a rogue account? So that's a really good question. So that kind of plays into the federation. So all of our accounts and highly recommended that you federate all of your users and roles and groups into your AWS environment from a central identity provider. And so by us having all that tied into ours, which is Okta, any user that becomes deactive in Okta automatically is deactivated in the cloud. And how do we identify any rogue accounts? I don't know if you want to clarify around if it's local user accounts or AWS accounts. So if you can answer that, then I can answer that much more easily. Cool. So I did want to give kind of an overview of what an organizational unit or org in AWS could look like. So this is straight out of their documentation for Control Tower. So in this case, we have a single management account that has a control tower deployed to it in an organization. And within that organization, there's multiple organizational units that are deployed. So we have a security OU. Within there, we may have infrastructure, we have some sandboxes, we have some exceptions, and we have some workloads. It's best practice now. I think this may be an older model to this one's kind of more layered. You want kind of a flat organizational unit structure so it makes it easier to apply these service control policies, but also you can only go so deep with the layers, and I believe you can only go 5 layers deep within organizational units. So just keep that in mind as you're designing this kind of thing. In our environment, we have a build account, and this helps us whenever we create a new AWS account, it automatically gets moved to the build OU. And what that means is we get extra permissions as the cloud engineering team to perform actions in there. We get administrative permissions. So before things are production, we're able to build out the infrastructure needed, and then we move it to its final OU, and our administrative permissions get removed as that happens in an automated way. We also have a decommission OU where we have similar permissions to be able to decommission all the resources within there before we terminate the accounts. Another key thing here to note is in your security OU, you may have sub accounts that do things like monitoring and logging and automation. Your logging account, you may want special policies in place that prevent the deletion of data within there, even if someone is an administrator. So that will protect you from having anything accidentally deleted. Another thing to consider is if you have a sandbox account, you may want to limit say the number of AWS regions that you deploy to, you're able to build resources in a sandbox. And that can kind of protect you from if there's ever an account compromise scenario or access keys are lost, at least the attacker can only create resources in the one region versus the 33 regions where you can it can be a pain to go in and delete all these resources across all of those, and it can sometimes be hard to identify that way. So those are some of the considerations. See, the question from Fernando is it possible to automate the management of accounts using Terraform, like apply controls, create roles, etc.? Yeah, absolutely. So by using either CloudFormation or Terraform, you can automatically deploy resources. Terraform is supported, I believe, within Control Tower now. You can actually deploy those resources to specific OUs using like CloudFormation stack sets and Terraform. And so based on the OU, if it's like a test org, you may automatically deploy and provision the administrator role for folks to be able to use, or you would not necessarily give administrator access to production accounts because you might want to maintain the idea of separation of duties and certain specific job function roles. So hopefully that answers that question. And I think there was another question in the chat. How did you decide what SCPs to use? How did you roll out SCPs to entire AWS organizations? So we try to follow AWS best practices. There's some good resources out there for SCPs and the AWS GitHub repositories. We also had some decided for us, to be honest, where we had compromises of a lab account where and access keys were accidentally shared to GitHub. And within 30 seconds, there was a case where someone from a Chinese IP address created resources in I think 22 different regions at that time. Within 60 seconds, Amazon notified us, and within 3 minutes, we were able to respond. But in that time, around 255 EC2s were spun up across those regions. Termination protection was enabled, and we had to go in and then deactivate those. And they weren't the cheap instances, they were the most expensive. So from that, we learned we want to deny certain regions if we're not in use. So we have standardized regions. From that, we identified some instance types we probably never want people to spin up, so we denied those. So that's a couple good use cases. Other scenarios where SCPs are beneficial is if you have compliance environments and you have a BAA assigned with AWS, you may want to deny the services that don't meet those requirements to be used in a BAA environment. So really it's kind of following best practices and then thinking about how you want to deny things, because SCPs, to be honest, are a little heavy-handed. We'll talk about identity and access management here in a minute, but if you deny something at the SCP level, that's an explicit deny. And now there's good logging about how to see that, but previously it was really hard to tell. But if you have an SCP denying something, even within the account, you can't allow it because it's that explicit deny. So hopefully that's helpful. So yeah, going into identity and access management, this is the most critical component of AWS security in my perspective. And what this service is free authentication and authorization service for within AWS. So in other words, it controls the who can access your resources and how they get access to that. And in some cases, what gets access to resources, because there's these things called service policies or service roles within AWS. And then you may be able to assign roles to specific entities within AWS as well that aren't necessarily humans. And highly recommend taking a look at some of the links down below if you want to learn more about IAM. So IAM allows you to create and manage AWS users, groups, and roles, and also if you have identity center permission sets, which is how you assign permissions to groups and users as well. Roles can be created and assumed from either other roles or services. For an example, you can assign a instance profile permissions to an EC2 instance. An example of where you might utilize that is if you have an EC2 instance that is running and it wants to access some kind of secure storage that isn't on its block device, like EBS storage, and maybe you want to put that into object storage. You might want to give access to an S3 bucket to either pull data down or to write data to. So you can put a policy on that EC2 to write to S3, so read and write, or just write directly to a specific S3 bucket. And there's examples of this across multiple AWS services where you might assign a role to that service or a resource within it. And you can specify permissions. So I kind of went into that a little bit, but which operations explicitly do you want to allow? And on which explicit resources do you want to allow it? So the example of the EC2 writing to S3, you would specifically call out S3 put object, and you would define that S3 bucket, and you can even define paths within that S3 bucket that you would allow that access to. And you can even put conditions on it. So I can say I only want this to work from within my specific VPC or from a specific EC2 instance as well. So that way something else couldn't take that policy and then utilize that or that role even within your own account. And then finally, IAM services provide access to not only the API, but the access management, the AWS management console, and the CLI as well. And if you're utilizing AWS Identity Center, you can utilize federated access to gain access to the CLI. It does that really nicely for you. Otherwise, you have to use some kind of third-party tool, like with an example being AWS Give Me Creds from Nike is an open source GitHub repo that allows for federated access. But Identity Center, if you're using that with single sign-on, it makes it a lot easier for folks to gain CLI access without using local users and generating these long-term CLI keys that then could be potentially lost or used or stolen. So give a second for any questions. So I did want to kind of go through the IAM policy evaluation logic. I kind of alluded to that already in terms of service control policies, but it's very important to kind of understand this logical workflow as you're working with identity and access management. So uh, by def it's also important to know that every action within AWS is an API call, and there's a service known as CloudTrail that logs those API calls as events. And you definitely want to centralize the CloudTrail, which logs all those API calls into a central security logging account, and then deny the access from editing those. But they can also be used to troubleshoot. So you want to make sure you don't just block it completely from view, because you may want to do some troubleshooting or incident response with that information. So by default, everything is an API call. And by default, there's a deny on everything. So similar to a firewall where you have the default deny, in IAM, everything's defaulted to IAM unless there's an allow that overrides that deny, or unless there's an explicit deny that overrides any allows. And so this is where that SCP comes into play, because if you apply a service control policy at the highest level, no amount of allows are going to allow that to work. So that's why you have to be kind of careful and picky about how you apply service control policies. And then the order to which the policies are evaluated isn't all that important. So I kind of give the workflow down below where, the very first step is it's going to be denied unless there's a policy that is pulled in for that user role or group. The evaluation, that policies are all evaluated. As if there's an explicit deny, it's automatically denied. If there's not an explicit deny, it's going to look for an allow. If that isn't there, it's denied. If there is an allow, it's then allowed. There's some exceptions to this. This is all within the IAM service itself, but then some services have service level policies on them, like S3, for instance. So you can actually put a policy on an S3 bucket itself to deny users or groups or actions. And so that would then come into play as well. But for this example, I just wanted to keep it simple. So how does IAM actually apply? We just went into like a little bit deep technical perspective, but to me, IAM is like a big balancing act across all of your environments. So like what permissions do people need to do their jobs, so that way you're not prohibiting or inhibiting them. But if you get too granular with things, it's going to create a lot of work for either the security team or the cloud engineering team. But if you're too permissive, obviously it can lead to exposures, vulnerabilities, or account compromise situations. So permissions are probably always going to vary by workload. So the way we kind of combat the complexity of this, at least from my perspective, is you manage the accounts that you care about very particularly, but then in like lab accounts, be a little more permissive. And that's where the multi-account strategy really comes into play. Because if you have an account full of developers doing development work, you may be a little more permissive than where you're deploying resources to do either compliant work or managing your ERP system. You may be a little more specific and granular, so you can pick where you put your energy based on this. And another good caveat that we kind of learned is to try to use AWS managed policies where possible. So within IAM, you can create your own custom policies that define explicitly what people are allowed and not allowed to do. But there's some policies that are managed by AWS itself and that AWS keeps up with, so you don't have to. So a couple examples of this is the policies for read only and then view only. So as Amazon introduces new services, they call out explicitly those services in their read only policy, which gives visibility into all of those services. And so you don't want to have to go in and modify your custom policies every time Amazon adds something new. So that's where you can take advantage of the managed policies. Since this is a security webinar, I do want to call out there's a key difference between read-only in AWS and view-only. Read-only gives access to actually download and have visibility into S3, which is storage, whereas view-only gives only visibility into a lot of the AWS resources, but not necessarily the ability to see into like CloudWatch logs or S3. So we typically default on specifically view only for folks that are kind of new to AWS. And so you don't accidentally give more visibility than you need to. And the final piece is the work really never ends with IAM, because anytime you're implementing something new, you always have to think about how all of this works and works together. So I'll pause there to give time for questions or comments. Okay. So the next thing I want to talk about is AWS infrastructure and data protection. And again, there's resources at the bottom of the slides for you to read a little more. I tried to link out the AWS well-architected framework is a good reference for this. So network protection is critical when you're deploying to the cloud. So it's important to know how your resources are going to be accessed from a networking perspective. So design with security layers and security in depth and purpose. So when you're building a new AWS account and you need to give access to resources, do you actually need private connectivity with your on-prem resources? And if not, then don't automatically provision that out. I know it sounds like common sense, but it's lessons that we've learned. So if you don't need that private connectivity, don't deploy it. And then think about, are there compliance requirements for this type of workload? If you're designing some kind of HIPAA compliant or controlled and classified CUI type workload, you're going to have different levels of security requirements for those networks. But on the flip side of that, design with scalability in mind as well. So if you're creating custom VPCs and networks for every single account, or in every use case, you're gonna potentially either run out of private IP space or make it so complex that it's hard to understand and manage. So that's where you can take advantage of the idea of shared VPCs. So with shared VPCs, you can actually create one centralized shared set of VPCs with its own subnets, with its own VPN connections or direct connects, but then they can be shared out to individual accounts to be utilized individually. And shared VPCs have been hugely beneficial to reduce the amount of peering connections that we have across our VPCs and networks, but also reduce the work of the cloud engineering team and operations team. Because it shares things like route tables, network access control lists, it shares that individual resources. It makes it easier to deploy. But one thing that shared subnets and VPCs don't share is security groups. So you can actually still have isolated security within these shared VPCs and subnets without necessarily uh, having to give up the isolation. So, or yeah, there's another question. So Tim asked, do you have a VPC flow logs turned on? They're pretty expensive, and GuardDuty already has context for AWS, underlying network logs to detect security events, trying to think through the use cases to turn on flow logs. We turn on flow logs by default for all of our non-generic default VPCs. So we do turn that on, and we actually have all those logs centrally sent via CloudWatch into a central logging account. So we can actually do cross VPC flow log analysis using a tool called CloudWatch Insights. We also send those logs to a central SIM tool as well, so they can be analyzed there for troubleshooting or security. I think we kind of accepted the cost of them because it's part of doing business in the cloud. And yeah, we definitely have GuardDuty enabled as well, and it does analyze some of that as well. So hopefully I answered that question. And then also think about your DNS scalability. So when we first went to the cloud, we kind of extended our own on-prem Infoblox implementation using Infoblox and then Bind. And what we've quickly realized is we weren't able to leverage some of the capabilities of the cloud, specifically AWS and Amazon Route 53. So over the past few years, my team and I have been working to migrate certain hosted zones into Route 53 so that they can be shared and then delegated out to individual accounts. So it makes it easier to manage, and we can leverage a lot of the capabilities of Route 53, like special routing policies and DNS firewalls and more. So that was a big thing. Did not mean to do that. So another thing to consider is design with automation in mind. As we're building resources out, we want to make sure we're thinking about how we can automate and deploy this as infrastructure as code. And that's important from a perspective of you're not designing yourself into a corner or building yourself into a corner and making it easy to leverage because teams aren't growing. So we have to make use of our resources the best as possible. And so that means being able to deploy with CloudFormation, deploys infrastructure as code, do the shared subnet type thing. And then also designing with redundancy from a network protection perspective. So um, we talked about the idea that AWS has this massive global presence. We talked about the different availability zones, but what we didn't talk about is how redundancy works with that. So one key design aspect is you're designing your networks in AWS is thinking about what availability, what region you're going to be in, what availability zones you're going to be in within that region, and how you deploy your subnets to them. Because if you were to deploy your subnets to all a single AZ and that availability zone goes down, then you just lost all of your resources. Or even if you have individual networking components within that subnet, say like a single NAT gateway egress point through one AZ, but even if you have multiple subnets within different availability zones, if that one AZ goes down where your NAT gateway is, then you just lost all internet outbound connections for those private subnets. So think about that as you build your resources. And the same goes for the conversation around understanding what services are global within AWS, like identity and access management, what services are regional, like S3 is across the whole region, and then what services are specific to availability zones. And in this case, if you have an EC2 instance with an EBS volume attached to it, all that has to be within a single AZ. So if that AZ goes down, you just lost that EC2 instance and that EBS volume. And if you did not have snapshots that are across the region, then you just lost all the data there. So it's important to think as you're building network, not just in terms of security, but also redundancy. Hopefully that makes sense. Um, the next I'll talk a little bit about compute protection. So we want to leverage, and in our case at Notre Dame, we consider ourselves fans or favoring Amazon native services. So we try to use managed services wherever possible to kind of take whatever shared responsibility we have and then pass that on to AWS. So like that example of using RDS over like a managed EC2 instance running our own databases on it, that's a decision point that you have to think about when you're considering protecting your compute resources. Another thing to consider is like when we went to AWS, we kind of had the decision of do we try to migrate and you leverage our existing security tools in AWS, or do we utilize what's already in AWS? And what does that cost us from a redundancy, resiliency, scalability standpoint? So I know some schools, in terms of using native tools, have decided to route all their traffic back through their firewall that they have on campus, and they utilize direct connects. Our perspective from a security standpoint was to leverage security groups and web application firewalls and resources in AWS for a little bit different scalability. That goes to also for systems managers. So that's how we do a lot of our patching and automation around patch groups and patch windows through our maintenance windows. And then we also try to leverage, like I mentioned, the automated deployment tools as much as possible and configuration management. So not just CloudFormation, but working to use Terraform or Ansible to build out your consistent resources over and over again at a secure level. And so that's been critical and crucial to us. We've also started utilizing a service called Image Builder within AWS, so we can build these golden images to then be utilized by Ansible, Terraform, and CloudFormation to be leveraged by teams across campus. So hopefully that makes sense. So Tim says, does your team use any endpoint protection tools like CloudStrike or Microsoft Defender? We leverage FireEye HX for now. I think we are looking at other tools like CrowdStrike. We can also utilize AWS Inspector from that perspective as well. It isn't as specific to preventing anything with Inspector, it's more detective. But yeah, we definitely utilize endpoint tools and we'll continue to do so. So continue with infrastructure and data protection. As you migrate to the cloud, it may be exciting. You may want to rush into it, but it's important to consider upfront things like tagging. So tagging is important for a number of reasons within AWS. It allows you to do things like reporting on resources in your environments. It allows you to do cost analysis. So if you add something to what's called a cost allocation tag, you can then use that in your reporting to find out how much things with specific key and value pairs are costing you across your whole environment. But one of the critical things that we utilize it for is security. So we can create certain environment tags. So a key of environment with a value of, say, production or test or temporary. And with those key value pairs, you can put separation of duties in place. So you can prevent the accidental deletion of resources and more. So that's where tagging is huge. And as you're deploying resources, slow down and think about creating this idea of a tagging dictionary and what are the required tags for all of these resources, what it has to be there, and how can you enforce those? And that's become very important to us and critical. And one way we've tried to kind of enforce that is deploying everything as code. And by deploying it as code, we can enforce it because the only way we deploy those resources is if those tags exist. On the same lines, you can have at the AWS control tower and organization layer, as well as SCPs, you can have tag policies. So you can define what tags are required, what tags are recommended, and then you can even audit on the tags if they're there or not as well. So that's an important thing to consider. But back to infrastructure as code. Personally, for our group, it's important that everything is in source control. And as we build things, we think about designs and pipelines as we're going through that. So there's some cool integration points with something called CodeStar and Code Pipeline with AWS, but you could utilize any kind of GitHub tool you want or any kind of CI/CD tool. The key thing here is thinking about how you can standardize on your deployments and reuse that code as much as possible. Some examples of where we've kind of standardized on these things are a standardized S3 bucket that meets Notre Dame security stamp of approval, has the right encryption, has the right logging, has the right lifecycle policies, and then folks can then utilize those throughout the environment to know that they've deployed S3 buckets that meet our standards every single time. And that's even a little bit of a balancing act as well, because some things you want to be more granular and specific to, depending on the environment you're deploying to. Another thing I like to think about from an infrastructure data protection standpoint is encrypting all the things, which sounds simple. It is really simple in AWS from a surface level. There's some gotchas when it comes to the key management service called KMS, because if you want to utilize KMS and do what's called customer managed keys, you have to make sure that everything is in alignment when you do DR and backups across multiple accounts. So it can get a little complicated and your key policies can be complicated a little bit, but getting that down is hugely important because you can just meet compliance requirements across the board just by having these CMKs in place or customer managed keys along with KMS. Another way that takes care of your encryption at rest using envelope encryption. Then your encryption in transit in a lot of cases can be taken care of with a service called Amazon Certificate Manager. And ACM or Amazon Certificate Manager can be applied to things like application load balancers, CloudFront distributions, which is your content delivery network, a way to expose your resources publicly through so both of those are great examples. And ACM can be applied to those, so you're no longer in the business of certificate management. So we deploy default ACM certificates to all of our new accounts as part of our automated deployments, and we make sure those are always DNS validated rather than email validated. So what that does is it takes the human out of the mix. So by using DNS validation in combination with Route 53, we're able to automate in an automated way deploy these certificates, validate them through DNS with Route 53, and then have those available for our load balancers and CDN using CloudFront in the account. What Certificate Manager does not do, though, is any local resources to like EC2 instances. You would still need to manage certain things, but with a combination of network load balancers and application load balancers, we found that that works pretty well to ensure encryption in transit. And finally, we'll talk a little bit about backups and disaster recovery. Anytime we're deploying things, if we utilize that example of the company that went out of business early on, they did not have proper disaster recovery, did not have proper backups in place, especially across accounts. So one of the things we always consider is Are resources only in one account? If so, we don't trust it. We always have a DR account that is read-only to everyone and that can only be restored from. And so we utilize AWS backup across all of our new accounts. We automatically deploy backup vaults to all of our accounts, and we automatically deployed backup policies that meet our standards in any compliance standards. And so what that means is if resources want to leverage our backup deployments, all they have to do is tag their resources appropriately, and they're automatically backed up. And if they use the right correct tags, they're automatically backed up across accounts to the DR account for the potential recovery later. And the policies of that is important to always consider your recovery time and your recovery points. Because if you only do DR backups on a backup policy once a day, but your recovery point is like within 8 hours, you're not necessarily going to meet that only with AWS backup. You may need to consider a different alternative backup solution. And then your recovery time is important just because of like what resources are you deciding to back up? How long would it realistically take you to recover that? And could you actually meet that? So this comes down to a governance and like strategy kind of thing. And finally, like test your backups. Like your backups aren't going to do you any good if you can't actually test those and validate those regularly. So, for example, our ERP system we test quarterly. We restore from a backup and then make that our new production version quarterly on a quarterly basis. So, no questions. I'll give it a couple more seconds for questions. I know I went really fast, but um, no questions. So finally, I wanted to cover incident response a little bit just because it's in the standardized solution framework here. So for centralizing as much as possible, that's one of our key things to think about because of that multi-account strategy. We don't want to be one-offing different accounts. We want to make things as automated and centralized as possible. So examples of this is the logging. So we enable a centralized CloudTrail bucket at our organization where all those logs go to automatically as soon as the accounts are created. Basically with our organization, no one can turn those logs off ever. So even if someone wanted to, they couldn't go in and then disable those logs. You can do that via service control policy or AWS organizations. If you enable it there, it means you can't turn it off. CloudWatch logs as well. We try to centralize those to a central place. And then monitoring and CloudWatch metrics as well. So along with the logs, you can have metrics around your EC2 instances, which can also be valuable for incident response and finding potentially compromised systems. So having all those go to a central place, but really only monitoring the things you need to go back to the original statement of certain things in AWS can cost a lot of money. And we found like some of the default metrics can cost upwards of thousands of dollars annually. So we customize and pick the metrics that we partner with our InfoSec team to decide what's important. And then from a learning perspective, we kind of create these default SNS topics that can get sent to either teams if they care about the specific metric alarm, or if it's in the case of like guard duty, we actually have those integrated with our ServiceNow system to automatically generate incidents to then assign it to the security team. In the case of the cost anomaly system, we actually have that integrated with ServiceNow. If there's an anomaly, it automatically generates an incident in ServiceNow and assigns it to my team. So that's where the integrations become very important. So who should be notified and how do they want to be notified? And we do all those integrations typically from a centralized automation account. And then finally, as you're building all these things out from an event-driven perspective, think about some of the event-driven automation that exists that you have capabilities of in the cloud that you may not have on-prem. And so think about things like event bridges. So we've gone from, in some cases, from Okta with an event bridge into AWS to generate automation. In some cases, we may be going from AWS with an event-driven thing to ServiceNow or directly to the security team. So an example of a notification you might see is if someone makes an IAM policy change that gives action star on resource star, that's something that you might actually want to automate the remediation of, remove that policy, and then alert someone. So that's some of the options that you can do there. And there's two questions in the chat. So Joel says, Since services such as guard duty and config generate billing with an individual account that scales with usage, do you get any pushback from those responsible? Typically not. We have an agreement where the security team will centrally fund guard duty. Typically for the workloads that are smaller, the costs are like 30 cents a month. For the large scale workloads where we have lots of operations, that's typically central IT anyways. So it hasn't been a big deal. And if people do push back, we're happy to help, take care of that funding from a centralized perspective. Uh, and then Tim asks, how do you perform incident response investigations? What tools do you use to analyze, correlate logs, and do you have any playbooks? And wanted to get some inspiration and starting points. So, Tim, I'm not sure if you have a Amazon account team available or a solutions architect, but I can probably send you links to things. But there's some pre-built IR playbooks and workbooks from AWS that are pretty helpful. Centrally, we do utilize a SIM. So in some cases, we're actually sending some of those CloudTrail logs directly to the SIM. In some cases, we're sending those flow logs or CloudWatch, so CloudTrail and CloudWatch to the SIM. And our security team might build out some alerts based on that. In other cases, we have it directly from AWS itself and kicking to my team in some cases. So it just depends on the scenario. But yeah, the playbooks, AWS does have some available that are free. And if you implement Control Tower, there's a lot of automated controls that you can put in place and enable at a cost that can take care of those things. So hopefully that helped. Cool. All right. So I think we're running slowly out of time. If there's any more questions, just feel free to reach out to me directly. So.
Oh, okay. You were actually at the last slide.
I
Thank
tried
you.
to time it.
You're 2 minutes left. So we can take maybe just one more question, and then we probably have to wrap up. That was very comprehensive. My mind's like going, 1,000 miles an hour with all the information. We can take one last question for James. Otherwise, I'm happy to send out your email address if that's okay to the group.
Absolutely. Yeah.
Great. Okay, if there are no questions, you probably answered all of them during your talk anyway. So just very quickly again, thank you so much, James, for this wonderful presentation. James will be running an AWS intermediate course in June. I had included the QR code earlier in the presentation. The recordings will also be made available. Yes, we are going to make a copy of this available, and I would be happy to send this out when it's ready to everyone that registered. And James will share the slides, so I'll send those emails out to the list. Okay, thank you. We are at time. Thank you, everybody, for attending. Thank you, James. So happy to have you here. We'll see you guys soon later.
Thank you. Thank you so much.
Bye.
Yeah.